What are negative voltage regulators and its application? Negative voltage regulators are electronic devices used to provide a stable, regulated output voltage that is lower than the input voltage. They function in a similar way to positive voltage regulators, but they produce a negative output voltage. Here's how they typically work. The input voltage refers to the voltage supplied to a device or circuit from an external power source. It is the voltage that the device or circuit operates on or processes to produce the desired output. In the context of negative voltage regulators, the input voltage is typically higher than the desired regulated output voltage. The negative voltage regulator then regulates this input voltage to provide a stable, lower negative output voltage. Regulation, in the context of voltage regulators, refers to the ability of the regulator to maintain a stable output voltage despite variations in the input voltage and load conditions. For negative voltage regulators, regulation ensures that the output voltage remains constant and within a specified range, even if there are fluctuations in the input voltage or changes in the connected load. This stability is crucial for ensuring proper operation of electronic circuits and devices that rely on a consistent power supply. Regulation is typically specified in terms of the regulator's output voltage tolerance under various conditions, such as changes in input voltage, load current, and temperature. A well-regulated negative voltage regulator will maintain its output voltage within a narrow tolerance range, providing reliable power to downstream components. Achieving effective regulation often involves the use of feedback control mechanisms within the regulator circuitry. These mechanisms continuously monitor the output voltage and adjust the regulator's operation to compensate for any deviations from the desired voltage level. In summary, regulation is essential for negative voltage regulators to provide a stable and reliable source of power, ensuring consistent performance of electronic systems and devices. Output. The output of a negative voltage regulator is the regulated voltage that it provides as its output. In the case of a negative voltage regulator, this output voltage is negative relative to its ground reference. The output voltage of a negative voltage regulator is determined by its design and specifications. It is typically set to a specific value, which is lower than the input voltage. This regulated output voltage remains relatively constant even when there are fluctuations in the input voltage or changes in the load. For example, if the input voltage to a negative voltage regulator is -12V and its output voltage is specified to be -5V, then the regulator will ensure that the output voltage remains at -5V, regardless of variations in the input voltage or the connected load. The stability and accuracy of the output voltage are crucial for ensuring the proper operation of electronic circuits and devices that rely on a consistent power supply. The output voltage specification of a negative voltage regulator is therefore an important factor to consider when selecting a regulator for a particular application. Applications of negative voltage regulators include operational amplifiers, op-amps, are versatile electronic components widely used in analog and mixed signal circuits due to their high gain, high input impedance, low output impedance, and differential input. They are often employed in negative feedback configurations to perform a variety of tasks, such as amplification, filtering, signal conditioning, and mathematical operations. In many op-amp circuits, both positive and negative supply voltages are required to ensure proper operation. Negative voltage regulators play a crucial role in providing the negative supply rail necessary for these circuits. Here's how negative voltage regulators are used in op-amp applications. Dual supply operation. Many op-amp circuits require dual supply voltages, typically a positive voltage and its corresponding negative voltage. The negative voltage regulator generates the negative supply rail needed for the op-amp to function correctly. This ensures that the op-amp can handle signals that swing both above and below ground potential. Biasing and DC offset adjustment. In some op-amp applications, it's necessary to bias the input or adjust the DC offset of the output signal. Negative voltage regulators can provide a stable negative voltage reference for biasing circuits or for setting the desired DC operating point. AC coupling. Op-amp circuits often employ capacitive coupling to block DC components and pass AC signals. Negative voltage regulators help establish the negative reference voltage needed for proper biasing and AC coupling in such circuits. Active filters and instrumentation amplifiers. Negative voltage regulators are commonly used in circuits such as active filters and instrumentation amplifiers, where precise control of both positive and negative supply voltages is essential for accurate signal processing. Audio amplifiers. In audio applications, op-amp circuits may require dual supplies to handle audio signals with both positive and negative voltage swings. Negative voltage regulators ensure the availability of the negative supply rail required for proper operation. Overall, negative voltage regulators are integral components in op-amp circuits, providing the necessary negative supply voltage to enable the op-amp to function effectively in a wide range of applications. In audio amplifier circuits, negative voltage regulators play a crucial role in providing the negative supply voltage needed for proper operation. Here's how negative voltage regulators are used in audio amplifier applications. Bipolar power supplies. Many audio amplifier designs require bipolar power supplies to handle both positive and negative voltage swings in the audio signal. Negative voltage regulators are used to generate the negative supply rail necessary for driving the output stage of the amplifier, which ensures that the amplifier can accurately reproduce both positive and negative halves of the audio waveform. Class AB amplifiers. Class AB audio amplifiers, which are commonly used in audio systems, require dual power supplies to operate efficiently. Negative voltage regulators are employed to provide the negative voltage rail needed by the output stage of the amplifier, allowing it to amplify both positive and negative portions of the audio signal. Preamplifiers and tone control circuits. In audio amplifier systems, preamplifiers and tone control circuits often require a stable negative supply voltage for biasing and signal processing. Negative voltage regulators ensure that these circuits receive the appropriate negative voltage reference for proper operation. Headphone amplifiers. Headphone amplifiers, whether integrated into audio devices or standalone units, may require dual power supplies to drive headphones effectively. Negative voltage regulators supply the negative voltage rail needed for driving headphone output stages, ensuring proper amplification of audio signals. Professional audio equipment. Negative voltage regulators are commonly used in professional audio equipment, such as mixers, amplifiers, and signal processors, where precise control of both positive and negative supply voltages is essential for accurate signal processing and high-quality audio reproduction. Overall, negative voltage regulators are essential components in audio amplifier circuits, ensuring that the amplifier operates reliably and delivers high-quality audio output by providing the necessary negative supply voltage. In telecommunication systems, negative voltage regulators are utilized in various applications where a stable negative voltage supply is required. Here's how they are employed in telecommunications. Line cards and interfaces. Telecommunications systems often include line cards or interface modules that interface with communication lines, such as telephone lines or data cables. These modules may require negative voltage supplies for functions like signal conditioning, line termination, or voltage biasing. Digital subscriber line, DSL equipment. DSL equipment, used for high-speed internet access over telephone lines, typically includes components that require negative voltage supplies. Negative voltage regulators ensure that these components receive the necessary negative supply voltage for proper operation. Central office equipment. Within telecommunications central offices, various equipment and subsystems require stable power supplies, including negative voltage rails for specific functions. Negative voltage regulators are employed to provide these negative supply voltages to ensure reliable operation of central office equipment. Power over Ethernet, PoE systems. PoE systems, which deliver power and data over Ethernet cables, may require negative voltage supplies for certain components, such as power sourcing equipment, PSE, or power devices, PDs. Negative voltage regulators help provide the required negative supply voltage in such systems. Telecom infrastructure. Negative voltage regulators are used in the infrastructure of telecommunications networks, including base stations, repeaters, and transmission equipment. These regulators ensure that critical components within the network receive the appropriate negative supply voltage for their operation, contributing to the overall reliability of the telecommunications infrastructure. Analog and digital signal processing. Telecommunications systems often involve extensive signal processing, both analog and digital. Negative voltage regulators play a role in providing stable power supplies to the various components involved in signal processing, helping to maintain signal integrity and system performance. Overall, Negative voltage regulators are essential in telecommunications systems to ensure reliable operation by providing stable negative voltage supplies to various components and subsystems involved in communication, signal processing, and network infrastructure. Test and measurement equipment encompasses a wide range of devices used to verify and quantify the performance of electronic systems, components, and circuits. Negative voltage regulators are frequently employed in such equipment to provide stable and accurate power supplies for various testing and measurement purposes. Here's how they're used. Signal generators. Signal generators produce electronic signals of various types, such as sine waves, square waves, and arbitrary waveforms, for testing purposes. Some signal generators require dual power supplies, including negative voltage rails, to generate signals with both positive and negative voltage swings accurately. Oscilloscopes. Oscilloscopes are instruments used to visualize and analyze electronic signals in the time domain. Negative voltage regulators provide the negative supply voltages needed for biasing and powering the analog and digital circuitry within oscilloscopes, ensuring accurate signal measurement and display. Spectrum analyzers. Spectrum analyzers are used to analyze the frequency spectrum of signals and measure parameters such as amplitude, frequency, and distortion. Negative voltage regulators supply the negative supply voltages required by the analog and digital signal processing circuitry in spectrum analyzers, contributing to accurate measurement and analysis. Multimeters. Multimeters are versatile instruments used to measure various electrical parameters such as voltage, current, resistance, and capacitance. Negative voltage regulators provide stable negative supply voltages for powering the measurement circuitry and ensuring accurate and reliable measurements. Power supplies. Test and measurement equipment often includes programmable power supplies for supplying precise voltages and currents to devices under test. Negative voltage regulators may be used within these power supplies to generate negative supply rails needed for specific test scenarios or applications. Data acquisition systems. Data acquisition systems are used to collect and record analog and digital data from sensors, transducers, and other sources. Negative voltage regulators help provide stable power supplies for the analog-to-digital converters, ADCs, signal conditioning circuits, and other components within these systems, ensuring accurate data acquisition. Environmental test chambers. Environmental test chambers simulate various environmental conditions such as temperature, humidity, and vibration for testing electronic devices and components. Negative voltage regulators may be used to provide stable power supplies for control systems and instrumentation within these chambers. In summary, negative voltage regulators are essential components in test and measurement equipment, ensuring stable and accurate power supplies for various testing and measurement applications, thereby facilitating reliable performance and precise measurement results. Industrial control systems, ICS, are used to automate and monitor industrial processes, machinery, and equipment in manufacturing, production, and other industrial settings. Negative voltage regulators are integral components in ICS, providing stable power supplies for various control and monitoring components. Here's how they are used in industrial control systems. PLC, Programmable Logic Controller Systems. PLCs are widely used in industrial automation to control machinery and processes. Negative voltage regulators supply the negative voltage rails needed by the digital and analog input-output, I/O, modules, central processing units, CPUs, and other components within PLC systems, ensuring reliable operation and accurate control. Sensors and transducers. Industrial control systems rely on sensors and transducers to measure physical parameters such as temperature, pressure, flow, and position. Negative voltage regulators provide stable power supplies for sensor interface circuits, signal conditioning circuits, and other components, ensuring accurate and reliable sensor readings. Actuators and motors. Industrial control systems often control actuators such as solenoid valves, relays, and motors to manipulate processes and machinery. Negative voltage regulators supply the negative voltage rails needed by motor drivers, relay drivers, and other actuator control circuits, ensuring proper actuation and control. HMI, Human-Machine Interface Systems. HMIs provide operators with a graphical interface to monitor and control industrial processes. Negative voltage regulators supply the negative supply voltages needed by the display controllers, touchscreen controllers, and other components within HMI systems, ensuring reliable operation and accurate display. Communication interfaces. Industrial control systems may include communication interfaces such as Ethernet, serial communication ports, and fieldbus interfaces for data exchange with other systems and devices. Negative voltage regulators provide stable power supplies for communication interface circuits, ensuring reliable data transmission and reception. Power supplies and distribution. Industrial control systems require stable and reliable power supplies to operate effectively. Negative voltage regulators may be used within power supply units to generate negative supply rails for various control and monitoring components, ensuring continuous operation and protection against voltage fluctuations. Safety systems. Industrial control systems often include safety systems to protect personnel, equipment, and the environment. Negative voltage regulators supply stable power to safety-critical components such as emergency stop circuits, safety relays, and interlock systems, ensuring reliable safety functionality. In summary, negative voltage regulators play a critical role in industrial control systems by providing stable and reliable power supplies for a wide range of control, monitoring, communication, and safety components, contributing to the efficient and safe operation of industrial processes and machinery. In electronic circuits, negative voltage regulators serve various functions, providing stable and regulated negative voltage supplies for specific components or subsystems. Here's how they are used in electronic circuits. Biasing circuits. Many electronic circuits require biasing to establish the DC operating point of active components such as transistors and operational amplifiers. Negative voltage regulators provide stable negative voltage references for biasing circuits, ensuring proper transistor operation and signal amplification. Op-amp circuits. Operational amplifiers, op-amps, are versatile components used in countless electronic applications. Some op-amp circuits require dual power supplies, including negative voltage rails, for proper operation. Negative voltage regulators supply the negative voltage rail needed for op-amp circuits to handle signals with both positive and negative swings accurately. Analog signal processing. Analog circuits often require stable negative voltage supplies for various signal processing functions such as filtering, amplification, and modulation. Negative voltage regulators ensure that these circuits receive the required negative supply voltage, maintaining signal integrity and fidelity. Digital logic circuits. While digital circuits primarily operate with positive supply voltages, certain applications may require negative voltage rails for specific components or functions. Negative voltage regulators can provide these negative supply voltages for digital logic circuits, such as level shifters, charge pumps, and voltage inverters. Display drivers. Display driver circuits, used to control LEDs, LCDs, and other types of displays, may require negative voltage supplies for biasing or driving specific display elements. Negative voltage regulators supply the negative voltage rails needed for display driver circuits to operate reliably and efficiently. Audio amplifiers. Audio amplifier circuits often require both positive and negative supply voltages to amplify audio signals accurately. Negative voltage regulators provide the negative supply rail needed for the output stage of audio amplifier circuits, ensuring faithful reproduction of audio signals with both positive and negative voltage swings. Voltage references. Precision electronic circuits, such as voltage references and precision measurement systems, require stable and accurate voltage references for calibration and accuracy. Negative voltage regulators can provide stable negative voltage references for such applications, ensuring precise voltage levels for calibration and measurement. Overall, negative voltage regulators are essential components in electronic circuits, providing stable and regulated negative voltage supplies for various applications, including biasing, signal processing, amplification, and control, contributing to the reliability and performance of electronic systems and devices.